All right, good morning all. Can everyone hear me? This is Orange County Sustainability Coordinator Kate Schmidt.
Yes.
Excellent. Thanks so much.
Morning.
Good morning all, and thank you for joining us. I am going to be slightly distracted because I have to make sure we admit people. That's why I like to wait a few minutes to keep getting everyone on board. But I am the sustainability coordinator as well as a land use planner, so I go back and forth with you guys for some years. And I thank you for joining us today to discuss this important information. I am going to ask everyone to stay on mute, please. While our speaker is speaking, we already heard background noise of the calls and the radio. So it would be fantastic if you could please mute yourself for now. We'll have an interactive Q&A afterwards, but in the interim, you are more than welcome to put your questions in the chat box so that we can get to them a little quicker. It also breaks up the monotony of the speaking. I know Ms. Candace, our speaker, would love that as well. And if you need it, you could put up your hand. I will admit there's a lot of you, so I have to be very cognizant to look for that hand. So you could always put it in the chat or private text me in the chat and I will definitely get to you. So, but use the chat box. The chat box is a wonderful area to exchange your thoughts, links that you're suggesting, your contact information. That would be great too. And I want to apologize that I am not on camera. The county does not provide cameras, and they didn't even provide mics until I had to beg for this 2 months ago. So I do apologize for that one, but we have our speaker on camera. So the state's a little bit more generous than the county. I also want to remind you that this session is being recorded and that it, along with the slides, will be available on the county website at orangecountygov.com/sustainability. I'll take this moment to remind our speaker, Candace, please make sure you send me your slides as soon as possible so I can get that up. That would be wonderful. And I'm also going to remind everyone that there's 2 hours of in-service training available, training credit available from the New York State Department of State. I just need you to make sure you signed up that way and you provided your your phone, what is this? The state issued code enforcement ID number. If you have any confusion, put it in the chat now. I'll try and help you. You also could follow up with it and email me, but the chat is the best spot because everything in that, not the chat, the registration's the best. You can go back and still do it, but all of that goes into one document to the state. So that is the best bet. And please make sure your numbers are accurate so we can get you that credit. Now, I am going to ask while we're waiting to make sure if any other late stragglers come in, if you could help me by using that chat box, a little bit of not homework, but classwork assignment right now. The county wants to know if you could please tell us your experience, your opinions, anything with solar and storage. It has been quite a ride the last 10 years, and we want to know more about what's going on in your municipality. Please realize that the county only sees projects within 500 feet of state and county roadways and state and county parks and property and ag districts. We don't know anything else that's going on, and we'd like to. And the only reason why we see that, that's part of the 239, New York State 239 General Municipal Law process. So if you could, use the chat box, tell me, because I want to know more. I also would like to know what your preference is for solar and storage moving forward in the future. Do you see parking lot canopies all throughout your municipalities? You don't have to get crazy. I don't want to tell you yet. Most of us will be retired by the time the technology is there, that the solar is in the roadway of all your local roads. But just realistically in the near future, what do you see going forward? What's your preference? How can we help? How can the state help? What are your needs? And lastly, this is the one that's most important. So it's 3-prong. Does your municipality have a plan to address any zoning in the future? And are you interested in learning about zoning? The county, Orange County, may be doing some sort of informal study in solar zoning, and we would appreciate all your feedback if you have any thoughts on this and if you'd like to get involved. So 3 things that I'd love to get in the chat, and you can do this at your leisure, but basically tell us your experience about what's going on in your municipality, and that could be commercial, residential, farms, parking lots, any complaints, any good things you want to commend the state or the county on. Number 2 is what's your preference moving forward? What do you see solar and storage going? And then the third one is if your municipality has a interest in thinking about solar zoning. And I don't mean the setbacks and the height restrictions. And we're going to talk about a little bit of that now today, I think. Hopefully we'll get to that. I mean more about how can we zone it appropriately and where you want it to go so that there is not some negative feedback from your constituents, as we've heard. So if you could think about that, get that in, that would be great. We will give a poll question somewhere at some point, but for right now, I'd like to introduce our speaker. So please welcome NYSERDA Senior Project Manager, Candace Rossi. Candace, I think you're unmuted.
Great, thank you, Kate. And thanks Orange County for having me here this morning. Nothing better than wake up your morning with a little energy storage code. So like Kate said, my name is Candace Rossi and I'm a senior project manager here at NYSERDA. So NYSERDA work on our clean energy siting team as well as our New York Sun team, but more focus on wearing my siting hat today, which some of you might be familiar with. Our team works with local governments across the state on any clean energy questions they may have. We develop resources and work directly with communities across the state on any issues relating to clean energy. So we will happily meet with your town or host a countywide workshop as we are this morning. So please take this presentation as an introduction to myself and our team as we're here to help you along the way as you work through clean energy projects or adopting laws or really any questions you may have. We are also consistently looking at what and how to develop resources to be best utilized by local officials. We don't really plan on just putting out a fact sheet and saying, here you go. We want to provide you with the tools and templates that can be implemented on the local level to be in line with your community's character. So like I said, we're happy to be a resource and please take this as an introduction. And if you ask a question that I don't have the immediate answer for, we're happy to go and do that research and help you figure it out as well. In this course this morning, we're going to do an overview of what battery energy storage systems are and do a detailed walkthrough of the 2020 Fire Code of New York State that is enacted in the last code cycle in 2020. This is also pulled out as a section of our energy storage guidebook, which I'll actually share a link in the chat in case you want to follow along as well. It is the 4th section, and that has basically the pullout of all sections of the code relating to energy storage. So it could be helpful as well. And although this title of the course may say it's for first responders, it's probably more helpful for code officials and all local officials to get an idea of the amount of safety requirements that energy storage systems must abide by due to the Uniform Code. So with that, this course is certified for in-service credits by the Department of State for the following 2 topic hours, so enforcement and administration, and 1 hour for the Uniform Code. So since we are doing this as an online course, there are some additional course attendance rules that must be met if you're looking to receive the Department of State in-service credit. Please be aware of these requirements to receive credit. So if you must be logged into this, basically this workshop for this amount of time, and please try not to log in and out 30 times because you might not receive that credit, because we will have to look at the registration form and Excel afterwards to make sure that you were spending your 2 hours with us so you can get the credit. So please just avoid logging in and out as much as possible. And additionally, I will ask some online questions as we go throughout this training this morning. So you can just put your responses in the chat, and this will also make sure we have a record of your participation if the Department of State requests this as well. All right, so now we'll get a bit into the course. First, we'll dive into an overview of energy storage systems, how they are used, different types and system size, really kind of build a foundation of knowledge of what these systems are. So then when we start walking through the code, it will make more sense of why the certain requirements might be in place. So New York has some of the most ambitious clean energy goals in the country, and batteries are going to be necessary to meet these goals. Renewable energy is an intermediate resource, and battery storage will help make the grid more reliable. So this is a basic example of what the grid of the future and almost today will look like. As an example of what's happening on the slide, the renewable energy resource or the grid will charge the battery, which will be dispatched to the home, building, or possibly used for grid services when it's necessary. So we'll get more into the different applications for energy storage as we continue this presentation, but this is how it's really working on its most basic form. So, when the sun is shining, it charges the battery, and then at night when the energy is necessary, and then the storage is able to dispatch that like to the house, building, or grid services, and vice versa. So now there are 5 overarching buckets of energy storage technology types. Pumped hydro is the one most people are familiar with. This consists of pumping water into an elevated reservoir when electricity prices are low and releasing it to spin turbines and generate electricity when demand is high. This is obviously not what one usually thinks about when they think about energy storage, but is an old energy storage technology and has been pretty prevalent across the state and the nation. Next, there are mechanical storage technologies, which look to harness kinetic or gravitational energy to store energy, like flywheels and compressed air systems. Compressed air systems are similar to pumped hydro, but utilizing that with compressed air. So instead of pumping water from a lower to an elevated pond in a compressed air system, ambient air or another gas is compressed and stored under pressure in an underground cavern or container. And then when the electricity is required, the pressurized air is heated and expanded in an expansion tube turbine, driving a generator for power production. So then we also have thermal energy storage. So thermal energy storage is looking to capture heat and cold to create energy on demand or offset energy needs. A facility can use off-peak electricity rates, which are lower at night, to produce ice, which can then be incorporated to a building's cooling system to lower demand for energy during the day. And next we have the hydrogen energy storage or chemical, where excess electricity generation can be converted to hydrogen and stored, and then the hydrogen can be stored and eventually re-electrified. And lastly, we have what we will be focusing on today and what you can anticipate to see mostly in your jurisdictions, which is electrochemical batteries. So each of these cells contain a positive terminal or cathode and a negative terminal or an anode. And electrolytes allow ions to move between the electrodes and terminals, which allows currents to flow out of the battery to perform work. So this is your lead acid battery, your lithium ion battery, the batteries in your cell phones, the batteries in your remote, TV remote. So these are ones that are just the most prevalent, the ones that are in EVs and along that nature. So this is what the course will be focusing on today. So now we'll hone in a little further on electrochemical battery types. All of these batteries we're talking about have 3 major components: an anode, a cathode, and electrolyte, which is just a medium to allow the current to go back and forth between the anode and the cathode. And basically charging and discharging the batteries just reverses the flow of electrons. The anode, cathode, and electrolyte can be made up of a wide array of different chemistries, and we'll get more into why that matters in a bit. The chemistry determines how the batteries perform. Depending on the chemistry, they may be more efficient, more or less expensive to build and operate, larger or smaller in size, and be able to provide electricity for varying periods of time. So depending on the application, different battery chemistries may be preferred. So you're probably most familiar with lead acid batteries, as they've been extensively used throughout the years, and they've been the standard battery type for decades. The lithium ion battery is where we're really focusing on today. These first batteries were used for consumer electronics, and now building on the success of these batteries, many companies are developing larger format cells for use in energy storage applications. Lithium ion batteries are in your phones, laptops, EVs, and they're currently the most popular and likely to be deployed. And they really do have like a higher energy density compared to others and is widely commercially available. So while we're looking at this chart, you can see that the lithium ion batteries tend to have a high round trip efficiency than the other types. So less energy is being lost in the energy storage process. So, you're getting most of the energy you're putting into the battery, you'll be able to get out of it as well. The typical duration is pretty standard from anywhere from, 15 minutes to 4 hours, as well as the time to build is pretty standard across battery types. The operating cost for lithium ion is relatively low. The cost of these batteries have fallen by 90% in the past 3 decades, and they require limited maintenance during their lifetime. They also have a very long cycle life. So the cycle life of the batteries is the numbers of charge and discharge cycles that a battery can complete before losing performance. So basically, you can see from this chart all the reasons why the market and industry, and basically nationwide, a lot of states are looking towards lithium ion batteries. So it's not shown in the chart, but different chemistries also present different safety considerations. And basically, we will go through that when we get into the details of the code itself. But this slide is really just trying to give you an idea of, out of all the electrochemical battery types, why are we seeing this more influx of lithium ion today? So here we have our first question for the course. So if you could just put your answer in the chat box. The first quiz question we have here is, why are lithium ion batteries increasing in popularity? And if you could just put, A, B, C, or D into the chat box. And once we have a good amount of participation, we'll kind of keep it moving. All right, looks like we have a lot of winners today. No good prizes yet, but the answer is D. It is all of the above. So that high energy density, the declining cost, and the fast dispatch time. So now we'll keep it moving. So we're going to continue honing in on electrochemical batteries. This slide is here to kind of demystify what we are talking about when we talk about batteries. I did talk a bit about this before, but energy storage systems usually consist of 3 components. First is the cell. This is considered the building block of the battery energy storage system. These tend to be very small, like the size of AA batteries or what's currently in your cell phone or TV remote. And when you start stringing cells together, that's when you get what's considered a module. And then when multiple modules are wired together, that creates the battery rack. So in the end, the battery racks are really just a bunch of really small battery cells wired together to create this larger unit. And the one thing that all of these energy storage systems will have is a battery management system. The battery management system is a technology that is dedicated to the oversight of the battery system, including monitoring the battery, providing battery protection, estimating the battery's operational state, continually optimizing the performance. It'll be able to report operational status to external devices. This is basically the brains, the eyes, and the ears of the battery system. The battery management system can monitor each individual cell within the system and make sure it's operating properly. If there is any issue outside of normal cell, module, or rack operating characteristics, it has the ability to isolate the cell to avoid it from damaging additional cells. So not only is it watching and making sure everything is operating properly, it can also manage and deal with any uncharacteristic issues that occur within the system. So basically, we have here Why are we even, looking at battery storage? Why is it becoming so popular nowadays? So most people are familiar with storage as a backup system in the event of a power failure, but it also has a lot of other largely untapped potential. So to think of it this way, energy storage can be cited at 3 different levels. You have a behind the meter system at the distribution level or at the transmission level. So I think this chart just gives you a really good indication of what all these different services that storage can be used for, and we'll just quickly walk through each of them so you can get a better idea. So first, we'll talk about the transmission level, or what's here is the ISO RTO services on the green side. So first we have what's called energy arbitrage. So this allows, storage will allow for the purchase of wholesale electricity while the location marginal price of energy is low. So typically during nighttime hours, and the sale of the electricity back to the wholesale market when the energy price is highest. So, this is a simple buy low, sell high application that storage can be used for. Next, you have the spin or non-spin reserves. So the spinning reserve is the generation capacity that is online and able to serve load immediately in response to an unexpected event, such as an unplanned generation outage. And then the non-spinning reserve is generation capacity that can respond to contingency events within a short period. So basically having that quick response time to anything that's abnormal going on the grid. Next is the frequency regulation. So this is the immediate and automatic response of power to change in locally sensed system frequency, either from a system or from elements of the system. Regulation is required to ensure that the system-wide generation is perfectly matched with the system level load on a moment-by-moment basis to avoid spikes or dips, which can create grid instability. Then it's also utilized for voltage support, which ensures reliable and continuous electricity flow across the power grid. And then lastly, you have what's considered the black start. So in event of a grid outage, black start generation assets are needed to restore operation to large power stations in order to bring out the regional grid back online. So most of these transmission level applications is just to ensure that our grid is being used stably and properly. So it just gives that extra level of resiliency. Next, we'll talk about the utility services. So that's the blue section of this chart. Utility services generally fall into 2 categories. It's basically a system upgrade deferral or resource adequacy and transmission congestion relief. So first, for resource adequacy, instead of investing in new generation, utilities can pay for other assets such as energy storage to incrementally defer or reduce the need for new generation. For the transmission congestion relief, storage can be deployed downstream to minimize congestion in the transmission system. And then for the transmission and distribution deferral, it's basically just delaying and reducing the size of or avoiding utility investments in transmission or distribution systems. And then last, we have the customer service. This is more what's going on, by local businesses and you and me and residents in your community. So providing direct benefits to end users. So first, we have the time of use bill management. So by minimizing electricity purchases during peak electricity consumption hours when the time of use rates are highest, and basically shifting these purchases to periods of lower rates. So this is similar to the energy arbitrage. It's basically, using storage to buy when the energy is cheap and utilizing it when the energy is more expensive. The demand charge reduction is a little similar as well, but it helps reduce a building's peak demand charge by shifting consumption times. Next, we have increased PV or solar self-consumption. So minimizing export of energy generated by solar systems to maximize the financial benefit of the solar. I would say maybe a few years ago when less of us were working from home, your home energy system would be producing the most amount of energy while we were all at work and not being utilized on site at that exact time, as residential usage tends to be higher in the evenings after we would necessarily get home from work. There might be a little shift on how we look at that today, but that's basically the the crux of that is just, being able to use the solar that you're producing yourself and not just exporting it. And then lastly, what everyone mostly thinks of when you think of energy storage is that it can be used as backup power. So the event of a grid failure, if there's storage paired with a local generator, you can provide backup power. So those are really the applications for energy storage. So we have at this point a quick basis of, how is energy storage working? How does the system itself look like? Why is the lithium ion becoming most popular? And now we have the different applications that storage can be used for. And though this is a lot of information quickly, just really want to create a basis for everyone to understand why lithium ion and why now. So next we have here is an example of why energy storage is taking off through the state. So across New York, peak electric demand is met in part by 50 oil and gas-fired peaker power plants and peaking units at larger plants. So these facilities include both combustion turbines designed to ramp up quickly to meet peak demand and aging steam turbines now used infrequently to meet these needs. So more than 1/3 of New York's peaker plants primarily burn oil, and 3/4 are over 30 years old, resulting in numerous inefficient plants with high rates of greenhouse gas and health damaging pollutant emissions for every unit of electricity generated. So as an example, on that really hot summer day, everyone has their air conditioners on. It's likely that that's the day the grid is at peak demand. Peak demand is the highest level of power that the grid may be using at one time on a daily basis. To ensure that the grid doesn't go offline, gas peakers are used to help meet this peak demand. Batteries have an opportunity now to provide the same service with greater capacity and a quicker dispatch time. And not only can batteries dispatch energy to the grid quicker, but it can also take energy off the grid if needed as well. Batteries are able to provide the same service, but would not need to be on such a stringent standby requirement, as they would be able to be used for other applications at the same time, but can still be prepared for those peak demand events. These peaker plants are also paid to be on standby. So even if there's not a peak demand event, they will be paid just to sit there and be on standby and be ready. Energy storage has that ability to replace these gas peakers, which have a much higher range of capacity. And they can also provide simultaneous grid services, while old peaker plants are generally slow to respond and are only used for peak demand because they are expensive. It is also true that peaker plants are typically disproportionately located in disadvantaged communities where vulnerable populations already experience high levels of health and environmental burdens. So renewable energy and energy storage systems are beginning to emerge as a competitive replacement for these fossil fuel infrastructures. Okay, so we just got a bit of an extensive introduction to what energy storage is, how it works, and why it's becoming more prevalent. Now we're going to review what the potential battery failure sequences and corresponding diagnosis may be. So one of the largest things that people are concerned about when it comes to energy storage events is thermal runaway. So thermal runaway is one of the primary risks related to lithium ion batteries. It is a reaction in which the lithium ion cell enters an uncontrollable self-heating state. Thermal runaway can result in off-gassing, high temperature, smoke, or fire, as you can see on the screen. There is also what we're referring to as the preventative region and the containment region based on how the risk has escalated. For example, if there is some sort of battery abuse, like a puncture or overheating of some sort that causes cell damage, the system may begin to off-gas. And as that off-gas continues, it may begin a heat release, which would cause smoking. So that could translate into ignition and a fire. So this is kind of a circular system or graph, how you can see how thermal runaway may occur in a battery. So like I said, the abuse can turn to off gases, smoke, and fire, and that cycle may continue if there aren't the right containment and preventive measures in place. And once thermal runaway has been started, it really cannot be stopped. So the energy storage needs to have a device that can recognize when the temperature is rising and the device should isolate the area and send a signal to the owner of the system that a problem exists. When there is battery abuse or off-gassing, there's still time to prevent the spread of a thermal runaway event. But once smoke or fire is visible, it's clear that a thermal runaway is underway and it'll just need to be contained. So here is the thermal runaway protection. So this slide shows that same image, but now with the different protections that are embedded into these projects and are required by standards and codes. In the preventative region, this is where the quality of the cell or the environmental system controls may be able to prevent a thermal runaway event. As we spoke about earlier, the battery management system will be able to detect that the system is not operating correctly and may be able to isolate the issue prior to propagating to the next cell. If there is off-gassing, the off-gas detection system and temperature monitoring should be able to give a warning, and you can prevent the system from continuing into the thermal runaway event. Once the system starts to smoke, you are now in containment mode as the system is in a thermal runaway event. As you can see, as the middle progresses, there are more safety measures in place to contain the event. So you'll hear more about each one of these controls as we go through the code. And just as awareness, as everything we are going to speak about going forward is in the New York State Uniform Code. So you won't need a local adoption as these protections are already required. So really just giving you a quick snapshot of, what is the risk with energy storage, and mostly it's concerning around thermal runaway and how are these systems being designed to make sure that this sort of event doesn't happen. And you can kind of see all the protections via preventative and containment that are on the screen and mostly embedded into the code itself. So before we get into the specific requirements, it's also important to understand the applicable codes and how we got here in New York State. In 2019, NYSERDA worked with the Department of State to adopt the 2019 Energy Storage Supplement that amended the New York State Uniform Code at that time. This stemmed from the limited provisions in the then 2015 International Code Cycle that were enacted in the state at the time. As New York recently put out incentives for energy storage, we wanted to make sure that each system was built as safely as possible. We didn't want to see these development to happen quickly, and safety was a real importance to us. So this amendment updated the energy storage fire code, fire safety requirements from the draft 2021 codes, and it is likely the most stringent codes in place across the country. The Uniform Code is the law statewide outside of New York City, which has their own codes. So this supplement has been incorporated into the latest code cycle as of May 12th, 2020. So it's fully incorporated into the Uniform Code, and this presentation covers the new requirements at a high level, but does not convey every detail of nuance. So always refer to the Uniform Code for complete system requirements. Now we'll move into the fire safety compliance as required for non-residential systems, which will include most commercial and utility scale systems. As part of our energy storage guidebook, we have pulled out most of the energy storage requirements and compiled them into our chapter 4, so you can follow along there as well. And it's also just a good resource to be able to see what is required on a local level. So also, as part of our storage guidebook, we do have a model law. So I think it's also important if you are looking on the local level to adopt a energy storage law, and you might go through the model law and not think there's enough requirements or stringencies in there. You can then flip over to section 4 and you'll see all that the code requires. So basically design that model law to ensure that it wasn't double saying what the code was saying. So in case the code updated, you didn't have to update your law, but there are a ton of requirements in the code, as you will soon start to see. All right, so to kick off this section, we're starting with the scope of the section of the IFC, which is relevant for all battery energy storage systems having capacities that exceed the value shown in this table. So any lithium ion battery system exceeding 20 kWh, so kilowatt hours, must comply with this section. If the system is in a group R3 or R4 occupancies, they will, comply with a different section of this code. But this is just giving you an idea. So anything that is over these capacity thresholds will have to meet these codes. So as part of the code, these are the construction documents that are required to be provided. So this is necessary along with the permit application. So we'll go through the code and go into more detail on many of these requirements and how they will be met. But as a minimum, they have to provide the location and layout diagram, details on the fire resistance ratings of assemblies, quantities and types of battery energy storage, the manufacturer specifications, ratings and listings, description of energy storage management systems and operation, location and content of required signage, details on the fire suppression and detection, thermal management, ventilation, exhaust and deflagration venting systems, support arrangements for installation, commissioning and decommissioning plans, and peer review identification and qualifications. So here we have the hazard mitigation analysis, which is only required for energy storage technologies that were not listed in that initial scope. When more than one technology is provided in a room or enclosed area, or where allowed as a basis for increasing the maximum allowable quantities. So we'll get into that in a few slides. But basically, any lithium ion system over 600 kilowatt hours will be required to perform this analysis. So this study is done to evaluate the consequences of failure modes. These are usually done by engineering firm for the town to determine the best approach on how to handle a failure. The analysis will evaluate the consequences of the following failure modes. So thermal runaway in a single energy storage rack, module, or unit, failure of any battery management system, failure of any ventilation system, if there's a voltage surge on the primary electric supply, if there's a short circuit on the load side of the storage system, what happens if there's a failure of smoke, fire, off gas detection or suppression, and a failure of the spill neutralization or containment system, which we will get into those specific requirements and systems as we continue through this. But really, this hazard mitigation analysis is doing that test to see what will happen if any of these failures happen. So then the fire code official may approve the analysis, provided that the consequences of the analysis demonstrate that fires will be contained for the minimum duration of the fire resistance rating, and detected in time to allow occupants to safely evacuate, that if there's any toxic or highly toxic gases released during fires, they will not reach the concentrations in excess of immediately danger to life or health level in the building or adjacent means of egress routes, and that flammable gases will not exceed 25% of their lower flammability limit and will be controlled. So this is really taking a high level view of, if there is a failure in the system, what are the responses and what are the consequences? So in addition to the hazard mitigation analysis, there's also a requirement for large scale fire testing. So where required, large scale fire testing must be conducted on a representative energy storage system in accordance with UL 9540A or an approved equivalent by an approved testing laboratory. So the test must show that a fire involving one system will not propagate to the adjacent system. Most of the design requirements for energy storage is to ensure that if there is an incident or fire, that it does not spread to a neighboring cell, module, or rack. It should also show that if a fire does occur, it will be contained within the area for the duration of the fire resistant rating of the room assemblies. So this test report must be provided to the fire code official for review and approval. There are a few requirements throughout the supplement that can be altered based on the results of a large scale fire testing, which we'll touch on as we go through this. So our next quiz question, what is large scale fire testing not supposed to demonstrate? If you guys could put your answer in the chat. All right, so it looks like we have mostly a consensus. The answer is A. So large-scale fire testing is not supposed to demonstrate that the fire will never catch fire. I mean, that the system will never catch fire, rather that it will show that if it does, it will be contained as necessary. And also this here pictured is a 20 megawatt system in Stillwater, New York, just north of Albany. So there's an image of a system that's currently installed. All right, so here we have the fire remediation requirement. So where a fire or another event has damaged the energy storage system, the energy storage system owner shall at their expense immediately dispatch one or more fire mitigation personnel to the premises and remain on duty continuously after the fire department leaves and until the damaged system is removed, or earlier if the public safety hazard has been abated. So this requirement was put in place to alleviate the local fire service of potentially babysitting a storage system if there's been some sort of fire or event. There is a possibility that a storage system may reignite after extinguishment, so the owner should be responsible for the safety of these systems. A fire remediation company will be called to the scene to relieve the fire department and start the decommissioning process. And once again, I'll highlight that this should be done at the expense of the system owner. So here we have the peer review requirement that's in the code, which is a bit unique, and I definitely encourage for local jurisdictions to take advantage of. So where required by the town, the system owner is responsible for retaining and furnishing the services of a registered design professional or special expert who will perform as a peer reviewer of the system. And the cost of the special services will be borne by the system owner as well. So as energy storage really is a new technology and a complicated one at best, this puts the onus on the applicant that they'll be required to provide you a peer reviewer or special expert to assist when looking at all this documentation. So where the scope of work is limited or focused in an area that does not require the services of an actual registered design professional or the special knowledge and skills associated with the practice of architecture or engineering, a special expert may be employed instead. If a special expert is hired, it's important to ensure that the scope of work is limited to their area of expertise as demonstrated in the documentation submitted to the fire code official for review. So the special expert must possess the credentials of education and experience in the area of practice that is needed to evaluate risk and safe operations associated with the design, operation, special hazards of the storage systems. So like I said, as this is emerging technology, it's not anticipated that every town will have the technical skills to assess the complete application. So this allows for that third-party expert to come in and assist to ensure that the project is properly installed safely to code. Next, we have the commissioning plan requirements. So commissioning needs to take place to ensure that systems will perform as intended and is required to occur prior to the project being placed in service. So the commissioning plan itself needs to include a narrative description of the activities that will be accomplished during each phase of commissioning, including the personnel intended to accomplish each of these activities. They'll need to provide a listing of the specific energy storage system and components, controls, and safety related devices to be tested, a description of the tests to be performed, and the functions to be tested. Conditions under which all testing will be performed, which are similar of the conditions during normal operation of the system. They need to provide documentation of the owner's project requirements and the basis of design necessary to understand the installation and operation of the system. They need to provide the verification that the required equipment and system are installed in accordance with the approved plans. They'll need to do integrated testing for all fire and safety systems. They need to do testing for all required thermal management, ventilation, or exhaust systems associated with the energy storage system. They'll need to prepare and deliver an operation and maintenance documentation, which we'll discuss more on the next slide. They'll need to provide training of the facility operating and maintenance staff, which will be important for your town. They need identification, documentation of the requirements for maintaining system performance to meet the original design intent during operation phase. They need identification and documentation of personnel who are qualified to service, maintain, and decommission the system and respond to incidents involving the system. So including documentation that such service has been contracted for. So this is really what we were discussing on the previous slide about fire remediation. This is where the system applicant or owner will provide that identification of who should be contacted in case of an incident. And lastly, a decommissioning plan, which we'll also discuss in the upcoming slides. So they need to provide all of that as part of the commissioning plan, and this plan needs to be approved prior to the start of commissioning. And then a commissioning report is also required that describes the results of commissioning and will be provided to the fire code official prior to the final inspection and approval. So there is definitely a bunch of requirements for these energy storage systems up front to ensure that they're being installed as safely as possible. So here is the operation and maintenance manual requirement. So this must be provided to both the system owner and to the system operator before the energy storage system is put into operation. The energy storage system must be operated and maintained in accordance with the manual, and a copy of the manual must be retained at an on-site location. So the operation and maintenance manual clearly identifies the required routine maintenance actions, has to include the name, address, and phone number of an agency contracted to service the system. It needs the maintenance and calibration information, including wiring diagrams, control drawings, schematics, system programming instructions, and control sequence descriptions for all of the system's components. It should outline desired control set points, a schedule for inspecting and recalibrating all controls, a service record log, a form that lists the schedule for all required servicing and maintenance actions, and space for logging retained on site. And inspection and testing records shall be maintained in the operation and maintenance manual. And here we have the decommissioning plan. So this is submitted as part of the commissioning plan. The town must be notified prior to system decommissioning, and the plan includes details on providing a safe and orderly shutdown of the system. That includes a narrative of the activities to be accomplished for removing the system from service and from the facility it's located in, and a list of any contingencies for removing an intact operational system from service and for removing a system that has been damaged by a fire or other event. And then to further safeguard against hazards, systems must also be listed in accordance with UL 9540, which is the standard for energy storage systems and equipment. Chargers, inverters, energy storage system management systems, if not already covered as part of UL 9540, must be listed separately. And then if it's a utility interactive system, the inverters must be listed under UL 1741 and labeled for that use. And if systems are repaired with anything other than identical parts, it will be considered a retrofit and subject to a permit application, and have many of the same requirements as a new system. So this is just making sure that all the equipment that is used is UL listed and safe and ready to be used. So once again, we have the battery management system. So this is considered an instrumental safety feature of the system and should be considered the eyes and ears of the battery system's health. This device is constantly monitoring the state of health of the system, and if the battery management system were to fail, the system would lose a major safety feature. This is probably the most important feature of the system in its effort to prevent the thermal runaway event, as it's able to detect anything that is abnormal and hopefully able to isolate it timely. So where required by the energy storage system listing, an improved energy storage management system that monitors and balances cell voltages, currents, and temperatures within the manufacturer's specifications. The system shall also disconnect electrical connections to the energy storage system or otherwise place it in a safe condition if potentially hazardous temperatures or other conditions such as short circuits or overvoltage were to be detected. So I know we've talked about this a few times, but this is a really important safety feature of an energy storage system because it's really letting you know what's going on at all times. So here we have the enclosure requirement. So once again, all energy storage systems enclosures should be made of non-combustible materials. This is to contain the fire within the enclosure so the heat does not transfer to other enclosures. So this is part of the preventative region for thermal runaway. If you're able to prevent it from propagating to another system, that's obviously highly preferable. So all enclosures must be non-combustible. So here we're going to start moving into the general installation requirements. And we'll begin with the electrical disconnects requirements. So electrical disconnects are extremely important to first responders, and they should be in a secure location with signage to direct the fire department to the proper place. Even though you may shut down the energy storage system, the stored energy inside the batteries does not just dissipate. So that is a key point to be aware of. This one device can shut down all cabinets or containers that are at the site, and firefighters should be advised to be careful when shutting down the system when there's no signs of fire. When there is a problem with a section of the system, the battery management system will generally isolate that particular section and stop it from charging and discharging. In the event of a fire, though, the fire department should definitely seek advice before shutting down the full system as the location. If there's no person to advise the fire department and there's a clear signs of fire, then the incident commander should shut down the system before any type of fire tactics are used. So here we have the working clearances. Access and working clearance space shall be provided and maintained about all electrical equipment to permit ready and safe operation and maintenance of such equipment. So this should be done in accordance with NFPA 70 or the National Electric Code and the manufacturer's instructions. So the clearance for working on equipment should be 3 feet according to NFPA 70, and these clearances should always be unobstructed. Fire departments that may go out to a site visit and should notify the owners of the equipment if they're not compliant with these regulations. Here we have that, rooms and other indoor areas containing energy storage systems should be separated from other areas of buildings and shall have a 2-hour minimum fire rating for all installations. The fire protection should also include the ceiling of the room that they're in, but this is not required for walk-in containers. Also, for indoor areas, energy storage systems shall be permitted to be in the same room as the equipment they support. I think this requirement might be pretty obvious why, but you definitely want to ensure that if there is an incident concerning fire, that there is enough time via the fire rating for the building to be evacuated to protect human health in general. Moving along, here we have the seismic and structural design requirements. Once again, this is pretty standard, so the installation will have to comply with the seismic design requirements in Chapter 16 of the International Building Code and shall not exceed the floor loading limitation. I think the need for this is pretty obvious and also standard. So when energy storage systems may be subject to impact by a motor vehicle, including forklifts, vehicle impact protection must be provided. The vehicle impact is always a concern and should prevent a vehicle from driving into the system. A vehicle that plows into one of these batteries can cause serious failures of the energy storage system and become a major challenge for firefighters. I think nobody wants a forklift driving into their brand new storage system because that would not be fun for anyone. But this is actually a picture of an installation down in Brooklyn or Queens, I forget exactly. So they have the pillars set up to avoid any impact. So continuing with general installation requirements, I think once again, this is a pretty common sense requirement. Any combustible material should not be located within 3 feet of cabinets containing the energy storage system or within a walk-in unit or room. Having a fire on the exterior of the system could possibly cause the batteries to fail and lead to a fire in the storage system. So usually a best bet to avoid any potential fires close to a storage system and just ensure that if there is any combustible materials, that they're just not stored close to energy storage. The next general requirement we have is for toxic and highly toxic gases. So systems that are installed indoors and have the potential to release toxic and highly toxic gas during normal use will be required to have a hazardous exhaust system. Some batteries may release toxic gases during normal charging and discharging. So a force fan system used in a battery charging room and other areas where gases can build up in a confined space. So this is, for example, a requirement for most lead acid batteries, as they could release toxic gassing during normal operation. Lithium ion does not release any toxic gases during normal operation, and therefore it's not required to utilize this ventilation. Although as we get to the later slides in the presentation and regarding thermal runaway protections, you'll see that many lithium ions batteries will install exhaust systems or ventilation, but it's just to meet other requirements in this code and not this one. Here we have the signage that is required for each battery energy storage system that should be provided on all entry doors to storage system rooms, to walk-in units located outdoors, on rooftops, or open parking garages on the enclosures of the cabinets. This is necessary to let people know that there are batteries in the location, what type of batteries, that it is energized, and emergency contact information in case of an incident. There may be additional signage that is required from the National Electric Code, but this is just specifically what is required in the fire code. You definitely don't want people randomly walking into rooms where these systems are. And if there is an incident, you want to be aware of what you are walking into, as we kind of discussed earlier, but not all battery storage systems are created equally. So you'll definitely want to know the type of chemistry that is inside. All right, so here we have quiz question 3. What is not required on the signage for entry doors for the battery energy storage rooms, areas, cabinets, or walk-in units? And also pictured here, we have Governor Hochul with a nearly 500 kilowatt system, which was part of New York State's first community solar and storage installation in Yorktown Heights. It looks like we have a consensus again. So A is the correct answer. So the name of the company who installed the system is not required to be on the signage. So we're still in the general installation requirements, and here is the security of installation requirement. You want to ensure that the systems are secure against unauthorized entry and safeguarded in an approved manner. Security barriers, fences, landscaping, or any other type of enclosures used should not inhibit any required airflow from the exhaust from the system. I think I was talking to a town one time who was wondering for an energy storage system, if they could just, you know, as a part of security and just safety, if they could just concrete around the entire thing so it's completely enclosed. And why that might, you know, sound plausible as a first thought. Once you get to your second thought and realize that you're not going to be able to ventilate the system, and actually that kind of, you know, security would cause a bigger issue. That's definitely not the way you want to go. So, you know, you want to have your installation secure, but you also need to make sure that they're still able to safely operate. And I think the most standard thing that people are doing, which is alongside the National Electric Code, is having that 7-foot fence that's locked, and, you know, making sure that any first responders would be able to access it if needed. Here we have the requirement for systems that are located in occupied work centers. So you need to ensure that they are locked in non-combustible cabinets or enclosures to prevent unauthorized access. Additionally, they must be placed within 10 feet of the equipment they support. Here, I think something you would see more for lead acid batteries and isn't really prevalent when it comes to lithium ion, but where systems are installed in a separate equipment room and only authorized personnel should have access to the room, and they shall be permitted to be installed on an open rack. This is a common theme, that you want to just make sure that all these systems are secure from unauthorized access, as they can pose hazards. So if someone is proposing that open rack installation, Once again, they need to be installed in a separate equipment room and only authorized personnel have access to them. So here I have our last general installation requirement. So this is for walk-in units. These units are defined as an enclosure that is not for human occupancy, but can be entered for maintenance, replacements, repairs, and inspection. The risk of the containers presenting a life hazard inside during an event is significantly less than with systems located indoors, especially when compared to non-dedicated use buildings. So basically, to keep it short, unless there is a reason you believe someone is inside this system, stay out of it. These containers are likely what you'll be seeing frequently throughout the state as energy storage is becoming more prevalent. Once again, this is the same system that I had referenced before that's down in Brooklyn or Queens. So they have these as walk-in units. And you know, it's not a place I would recommend going for lunch. It's really not too roomy inside. So you really want to stay out of these as much as possible. So we just went through all the general installation requirements that all systems within the scope must meet unless there's a specific exemption listed in the code. And now we'll begin the electrochemical storage system protection requirements. So first one we have here is the size and separation. And if you can remember back to our little circle chart regarding thermal runaway, this is one of the first preventive measures that are put in place to try to avoid propagation. So here is the size and separation requirement. Grouping of energy storage systems to a maximum of 50 kilowatt hours is there to reduce the fire load of a group or a rack. This grouping does not apply to remote outdoor installations. It does, however, apply to walk-in containers or cabinets that are outdoor and near other exposures. Walk-in units that are near exposures, while they need spacing between groups, do not need spacing between the wall of the walk-in unit. It also applies to energy storage systems that are in some rooms or areas that are indoor. There are two exceptions to this requirement. One is for communication utilities, and one is based on that large-scale fire testing. So as we spoke about earlier, this is one of the requirements that based on large-scale fire testing, that there will not be propagation of fire or any other hazards. This requirement can be changed per the fire code official. And I will say that often for walk-in units, smaller separation distance are allowed based on the result of large-scale fire testing. But once again, this will have to be something that the applicant shows you and that the fire code official approves. So this slide here is for the maximal allowable quantities. So this represents the maximum allowable quantities that were discussed earlier in the presentation. If an installer wants to exceed the values listed in this table, they will need to conduct the hazard mitigation analysis and the large-scale fire testing to show that the system will still be safe. There are two other exceptions. That is for lead acid or nickel batteries under the control of communication utilities and for projects that are located in dedicated use buildings. Also of note, you can see here that lithium ion systems exceeding 600 kilowatt hours will need to go through the additional testing. If you are at all familiar with NYSERDA's model battery energy storage system law, this is the reasoning defining systems into two tiers, over and under 600 kilowatt hours. So with projects over 600 kilowatt hours having many more requirements that they must meet. And here we got question number 4. So for lithium ion battery systems exceeding 600 kWh, hazard mitigation analysis and large scale fire testing are both required. True or false? I feel like that one might have been too much of a layup considering the last thing I said, but it's all good. And yes, you're all correct. The answer is A. So all those projects will need to go through that analysis and testing. So this is a requirement for mixed electrochemical systems in a single area. We'll see this when people use a different battery chemistry that are used for critical operating protection systems, maybe alarms or certain ventilations. These critical components should always work when the energy storage is completely shut down by a first responder or the battery management system. So basically, it's just a pretty simple formula to ensure that the total aggregate quantities of the systems, it's basically determine what that should be. Next, we have the elevation requirement. So the IFC have used this language for many sections within the fire code. The system cannot be located higher than 75 feet above the lowest level of fire department vehicle access or on floors located below the lowest level of exit discharge. So there are exceptions for each of these systems if approved by the fire code official. They can be permitted on higher or lower floors based on the additional mitigation analysis or large-scale fire testing. They can also be permitted in underground vaults if approved by the fire code official. And once again, there are specific batteries, lead acid and nickel for communication utilities that don't have to meet this as well. So the fire department officials do have the right to permit these projects on higher floors, but only if they feel comfortable with the energy storage safety features and that the fire protection systems that are installed. So moving along, we have the fire detection requirement. So when systems are inside a controlled room or enclosure, the smoke alarm is generally the easiest way to sense a fire. And you're going to need some sort of automatic smoke detection system, or it might be a radiant energy sensing fire detection to be installed. And all of these alarm signals shall be transmitted to a central station. So, all those alarms are going to be hooked up to the battery management system, and you'll be able to monitor if there's anything going on. So central stations are used to monitor fire alarms and make notifications to the fire department at a location sending a signal from a smoke detector or a radiant heat detector. So once again, this is just another preventative tool to ensure that the system is not going into thermal runaway. And if it is, getting the appropriate personnel there as quick as possible. This is the fire suppression system requirement. This is necessary as a containment response to any thermal runaway or other issues in the system. These systems can be set up as a sprinkler water system or usually a clean agent-based system. So there's the automatic sprinkler system that requires the minimum water density as you see there, or whatever is determined based on large-scale fire testing. Although the code calls out that this water density, there may be a challenge to get that much water density to upper floors of a high rise or an area that does not have good water pressure. So in outdoor locations, some towns are using a dry pipe that the fire department is supplying the water. This is used so that the automatic water suppression systems do not accidentally freeze or malfunction and cause the water to flow on a system that has no problem. But once again, this is up to the applicant and the local town to have those discussions of what's going to be put in place. Or you can utilize an alternative automatic fire extinguishing system as listed here if they're approved by the fire code and based on large scale fire testing. So you'll see that as we go through this presentation, there are a few requirements that can be adjusted or accepted based on that large scale fire testing to just make sure that the system will safely respond to any sort of issue that's occurring. So here's images of a fire suppression system. And once again, this is actually from that project that I've stated a few times that's located down in Brooklyn or Queens. So this system utilizes both a water and a clean agent gas system. So the sprinkler heads on the water have basically that little glass bulb, or, it's basically once it's able to be melted out that the water can bust out and come into the system. So it's basically a bit more automatic that way. And then there's also the clean agent link, which can be basically put into use by the battery management system as needed. And then here is that dry pipe, this dry standby pipe. So a standby pipe is that type of rigid water piping, which is built into usually multi-story buildings in a vertical position, or in this case, into a walk-in energy unit, to which fire hoses can be connected, allowing the manual application of water to the fire. The pipe is in place permanently with an intake usually located near a road or a driveway so that a fire engine can supply the water to the system. The standby pipe supply extends into the building to help supply firefighting water to the interior of a structure via hose outlets. So dry standpipes are not filled with water until they're needed in firefighting. So basically firefighters often bring hoses in with them and attach them to the standpipe outlets located along the pipe through the structure. And like I said, this pipe is going more directly into the standby unit. And this is once again the same system as the previous slide. So once the fire department hooks up basically to the standby pipe, that is what's being utilized into this water pipe into the system as well. So basically via this system, if there is a fire, the water is getting directly in there and will likely flood the entire container. So here we have the maximum enclosure size. So these enclosures have volume limitations. As the energy density continues to get smaller and smaller, responders should be aware that a lot of energy can be stored inside these containers. The original supplement had the requirement being the dimensions that you see on the screen, but when it was adopted into the uniform code, they opted for a volume requirement instead. So that 4,028 cubic feet is also basically equating to the 53 by 8 by 9.5. So you'll probably just see more of the standardized containers, but as technology shifts and changes and evolves, they had decided to go for a volumetric approach. So here we have the vegetation control. So 10-foot distance is needed for all vegetation except ground cover, such as grass. This is to prevent a fire from spreading to different locations outside the enclosure. And once again, it's actually allowed for reduced clearance to combustible vegetation shall be permitted based on large-scale fire testing. I assume that won't happen very often, as 10 feet seems to be a sufficient setback that projects will be able to meet. And also separately, depending if you have a local law, you might have other setbacks in there that they'll also have to take into consideration. So here we have the means of egress. So egress from an open parking garage is very important, and these systems should not be within 10 feet of those pathways. A code official can approve smaller distances also based on large-scale fire testing. But you want to make sure a continuous and clear path from any occupied portion of a building to a public way, such as an outdoor sidewalk. So a means of egress consists of 3 parts: the exit access, the exit itself, so door C outside, and the exit discharge, the route from the exit to the public way. So this requirement for outdoors and open parking lots, you want to make sure there is a means of egress if there is an issue. So we've just covered all the requirements for all commercial systems, and majority of the requirements are put in place to prevent a thermal runaway event. So now we're going to talk about the different requirements necessary for different battery technologies. Like I had said in the beginning of the presentation, not all batteries are created equal, and different chemistries lead to different safety compliances that are required. So here's the chart that is included in the code. So this table is showing battery technology and giving a glance of some of the protections that are needed for specific chemistry types. As battery chemistries differ, there are different requirements for each chemistry based on their subsequent hazards. And once again, we are seeing a majority of lithium-ion batteries coming into New York. So this is not in lieu of the previous requirements we discussed, but in addition. So you can see the 4 different battery technologies that they've called out as part of the code. Lead acid, nickel, lithium ion, and flow. Lead acid is required to meet all of the compliances that you see on the screen. Same with nickel. Lithium ion is only required to meet the explosion control and thermal runaway compliance. And as we go through each slide, I'll kind of give you an idea why that is. And then also flow doesn't require the last 3 as well. Basically, if your storage system is not located here, you will need to meet all of the compliances unless you can provide some sort of justification of why it's not required. So the first one we have here is the exhaust ventilation. So exhaust ventilation is required for rooms, areas, and walk-in energy units, storage units that contain certain electrochemistries. This is not required for lithium ion, but is for all other battery types. For example, lead acid batteries are capable of releasing hydrogen gas due to overcharging or other events. So this ventilation requirement is really focused on that. The applicant will need to install a ventilation fan for walk-in units with battery chemistries other than lithium ion. So the ventilation needs to be designed to limit the maximum concentration of flammable gas to 25% of the lower flammability level, or provide continuous ventilation. There needs to be standby power for at least 2 hours and needs to be supervised by a remote station. Will likely also be part of the battery management system. And it may be required for lithium ion as a method of explosion control, which we'll discuss in a few slides. It may be required for a responder to remove flammable gas due to a thermal runaway event. So the turn on switch should be remote from the system, and signage should always be used to direct the responders to the ventilation fan. And also, as part of the exhaust ventilation requirement, a gas detection system is required to monitor the levels of gas in the unit. This will trigger appropriate ventilation and inform operators of unusual levels of off-gassing. So any failure of the gas detection system will also trigger a trouble signal. So here we have the spill control and neutralization requirement. Some energy storage chemistries have a liquid corrosive electrolyte. These corrosives can burn skin and damage first responders' PPE. The responder should follow their department's standard operating procedures when responding to corrosive spills. So once again, this is really important to have the appropriate signage for the system so they know what they're dealing with, and also have that training as part of the commissioning plan for your first responders. So some of these systems can contain corrosives that can be well over 1,000 gallons, and these systems should have secondary containment, and in some cases might need that third level of containment. So lead acid is the major example here, as the battery has a liquid electrolyte, so they have a higher risk for spill control. And lithium ion batteries electrolyte is not liquid, so this is not a safety requirement for them. So here we have the explosion control requirement that's necessary for all battery types. Explosion control can be handled in 2 ways. We have deflagration venting, which it utilizes pressure panels. And then if there's enough built up gas pressure in the unit, it will push open the panels and release the gas. Most lithium ion systems will have deflagration venting panels that will manage the overpressure blast wave that is produced in an explosion. That blast wave will be sent through the venting panels and should maintain the integrity of the container. These panels' venting direction should also be directed to an area that won't interfere with the fire department's operations. So you can see an example of this on your screen. This is that same system that's located downstate. So they have the panels on top of the container, and then if there was some sort of an event, those would blow open and it would just go up. It would not affect with any of the fire department's operations. And they had actually worked with the FDNY to make sure that was in compliance for them as well. And then the other requirement that they can do is the deflagration prevention. So this can be done using exhaust fans and limiting the lower flammability limit to 25%. This is a requirement that we will see having developers put exhaust vents and fans in their lithium ion systems. So like I said, while this lithium ion is not required to have exhaust ventilation as part of the other 2 requirements that would require them, they can utilize that as part of their explosion control requirements. And I will say, I think majority of the time they are putting those in. So here we have the safety caps. So once again, this is not a requirement for lithium ion batteries. This is referring, so the safety caps is because hydrogen is a byproduct of some batteries, such as lead acid, battery charging and discharging process. So rooms or containers that have these systems should have a ventilation fan inside that will turn on when the flammable gas levels reach that 25% limit. And basically in valve regulated lead acid batteries, the gas is captured and then released when the pressure on the safety caps reach a point that is considered overpressurized. So basically these caps will open and release the gas buildup. So coming back to the thermal runaway, which has been woven through this presentation, once thermal runaway is started, it cannot be stopped. So energy storage systems should have a device that can recognize when the temperature is rising, and the device should isolate that area and send a signal to the owner of the system that there is a problem. Data testing has shown that the stopping of charging and discharging of a cell is an effective measure to prevent a cell from going to thermal runaway. So you have here on the screen to the right, basically the separate stages. So, in one, you might, so here you're basically looking at what would be a module. So you might have an overheat or overcharge or piercing of one cell, and that, the heat and everything starts moving and running away to the next cells. And then, that is the beginning of a propagation. So you need to make sure you have a device to help prevent, detect, and minimize the impact of thermal runaway. And I'll also state that we've already talked about a ton of requirements at this point. Most of them were in that circle chart showing the different preventative and containment mitigation features that are necessary for thermal runaway. So then this is just throwing in another, making sure that those are being met. So there's just basically a ton of safety features being required by the code. And now we have question 5. So do all electrochemical battery energy storage system types require the same fire safety requirements? And you could just put your answer in the chat as we've been doing. And once again, we got a good consensus that the answer is B. So many safety requirements vary based on hazards associated with the different chemistries. All right, so to review, we've gone over the requirements that all commercial and utility installations will need to meet, as well as the additional requirements based on their chemistry. So now we'll go over the different requirements based on where the system is located. So here we have an overview of the different locations we are going to talk about and how the requirements differ. So there's really 4 major locations that are determined and defined in the code. You have the dedicated use building, the non-dedicated use building, outdoor near exposures, and outdoor remote. So first we'll discuss the dedicated use buildings. So these are buildings that are only used for battery energy storage, electrical energy generation, or grid related operations. There's no unauthorized access, only maintenance. And if separate areas are needed for admin, no more than 10% of the building and direct may be that, and there must be a direct means of egress. So once again, this is not where you're planning your lunch date. You're not gonna be just hanging out in one of these buildings. They're really meant to be a dedicated for energy storage, and that is all. So here is just another example of maybe what a large dedicated use facility may look like. I mean, it doesn't even look like a fun place to have lunch. You might just get lost. So continuing on, here we have for indoor installations, the non-dedicated use buildings. So the code thought real long and hard of how to define this, and it is defined as basically it contains energy storage and is not a dedicated use as described on the previous slides. So basically examples of this are colleges, work centers, residential apartment buildings. And this slide shows a few pictures of systems installed in these mixed use buildings. So this is a list of the compliance that indoor installations need to meet. We have already reviewed the general installation requirements, the electrochemical protections, the chemistry specific protections. And here you can see the different requirements that indoor installations might be required to meet, debating on their use. So for dedicated use buildings, they must meet, the general installation requirements, the size and separation, but they are not required to meet that maximum allowable quantity. So they can go over that 600 kilowatt hour for lithium ion without doing a large scale fire testing, though it is very, very extremely likely that they'll still have to do that testing for other reasons. Just it won't be required due to that one requirement. And you can see down here where it gets to 1206.14, those are the specific ones for indoor installations, which we'll talk on the following slides. And then also has the requirements for the technology specific protection, which is what we just went over, which is based, the requirements specifically for a lead acid or lithium ion. And then you can see for non-dedicated use buildings that all of these requirements are necessary. And that has a lot to do with a higher threat to human health, as if this is being installed in a college or building that is used for mixed use, you want to make sure you have as much required protections in place as you can. So next question we have here. So for indoor installations, which of the following is not required for both dedicated and non-dedicated use buildings? All right, looks like we have the consensus of C, which is correct. Dedicated use buildings may exceed the allowable quantities requirement, so they are not required to meet it. I think next time I have to make my questions harder. These are all too easy, it seems. But continuing on here for indoor installations, which both dedicated and non-dedicated must meet, is that they shall not be installed inside a dwelling location. So when energy storage fails, it may release toxic fumes that can overcome a human being very quickly. So for these reasons alone, the risk is too great. I don't know if you really want to be sleeping next to your storage system, to each their own, but the code has decided that they cannot be installed in dwelling units or sleeping units. And then the last additional requirement that indoor installations have to meet is the fire resistant rated separations. So 2-hour fire barriers are needed in a room or area for indoor installations. And basically for dedicated use buildings, this must be used for being put in place to separate from admin and support personnel. And then for non-dedicated use buildings, it's basically any room separate from the other building areas. So majority of it will have to be rated with this fire resistance. So moving along, those were just the specific indoor installations. So now we're moving to the outdoor installations. Outdoor installations are defined as either being remote or near exposures. So remote outdoor installations is considered anything that is 100 feet clearance from buildings, lot lines, public ways, stored combustible materials, hazardous materials, high piled stock, and other exposure hazards. And then installations near exposures is once again just not remote as described above. So here, once again, we have another chart showing the requirements for outdoor installations. So remote systems may not have the same requirements as outdoor installations near exposures. These remote systems do not have the same life safety risk factor involved, so their requirements are less stringent. And you can see this here specifically when it comes to the fire suppression systems. It has a fun little asterisk. So where approved by the fire code official, fire suppression systems are permitted to be omitted. So why it is a requirement for remote installations. Basically, if the applicant can prove to the fire code official that this is not a requirement or their project shouldn't be subject to it, you are allowed to omit them. And then you can also see for remote systems that size and separation is not a requirement, and the maximum allowable quantities is not a requirement either. And once again, this is based on the fact that they're further and don't have as great of risk to life, human health. So, and yes, so we'll continue. All right, so the next quiz question. So for outdoor installations, which safety requirements are not applicable if the installation is considered remote? All right, you guys are crushing it. The answer is D. So like I said, both size and separation and maximal allowable quantities are not required for remote outdoor installations. So here is an example of a walk-in container. You can see, here that there's the maximum enclosure size is being met. There's a means of egress. They have security of the installation with the fences. They have like the HVAC units and exhaust ventilation to meet that explosion control. So this is kind of just an example of what a project might look like. And this one is definitely quite large. It's a 120 megawatt installation out in California. So continuing, this is just another example of what a walk-in unit looks like. And like I said, this is likely what you'll be seeing majority of when applicants might be coming in with a 2 megawatts, a 5 megawatt solar project. A lot of them are now looking to pair it with energy storage, and these are usually the systems size that they're looking to do as well. So once again, they have the fire suppression system, an energy management system, HVAC. You can see the battery rack, how it's kind of situated. And yeah, definitely just don't want to be in there if you don't have to be. And then these are the energy storage cabinets that we've discussed a bit today, just to give you an idea of what those look like. And this is just an example of an outdoor cabinet system. And you can see the system, if it is remote, that, size and separation compliance wasn't required, or maybe that they were able to get that waived because of large scale fire testing. But that's just kind of an example of the different outdoor systems you'll likely to be seeing. All right, so the additional requirements for outdoor systems. So there's a requirement for clearance to exposures. So once again, there needs to be over 10 feet clearance from lot lines, public ways, buildings, stored combustible materials, hazardous materials, high piled stock, and other exposure hazards. And you're able to reduce this clearance to 3 feet from all exposures. If you have a 1 hour fire barrier 5 feet above and around the system boundary, and then for buildings, if the wall adjacent to the system is non-combustible. So there are different exceptions to certain requirements throughout the code. And then additionally, if the outdoor installation is being installed on an exterior wall, so the system may be installed on exterior walls if the max capacity of each unit is under 20 kilowatt hours. Otherwise, they'll have to meet compliance with section 1206.15. They have to be installed according to the manufacturer specifications. The individual unit separation must be greater than 3 feet. Units greater than 5 feet from doors, windows, operable openings into buildings, or HVAC inlets. And once again, there might be the possibility for smaller separation for 4 and 5 based on large scale fire testing. So basically for the past two, or for the indoor and outdoor installations, like I said, they all have to meet the general installation requirements and the technology specific requirements. And then for the indoor, they did have those 2 additional requirements. And then we just discussed the 2 additional requirements for the outdoor installations. So next we have what the code defines as special battery energy storage installations. So these are projects that are basically the rooftop installations, so installed that are located on roofs of buildings, and then the open parking garage installations. So these are installations that are located in a structure or portion of a structure that compiles with that section of the building code, which is regarding for parking garages. So once again, they will have to meet all the general installation requirements that we've gone over, alongside the size of separation, maximum allowable quantities of smoke and fire detection. And as you go down, there is some additional requirements that are in 1206.16. So, almost the bottom 4, and then they're still required to meet all the technology specific protections. So basically, no matter where these systems are installed, they must meet that technology specific protections that we went over, which was like the thermal runaway, the explosion control, the spill neutralization. And then there are, specific ones for, like, obviously the rooftop systems do not need to meet the open parking garage installation requirements, and vice versa. So the special installations, they have a specific clearance to exposures as well. So they have to have a clearance of at least 10 feet from buildings, except buildings on which the energy storage is mounted. Any portion of the storage building elevated above rooftop on which the system is installed, from lot lines, public ways, stored combustible materials, locations where motor vehicles can be parked, hazardous materials, or other exposures. So I think the constant theme when it comes to clearance to exposures is you blatantly do not want your energy storage system being installed next to anything that might be combustible or might cause the project to basically act abnormally. So you want to make sure that these, the systems are secure from access and aren't being basically having other things too close to them to make anything go awry. So here we have the fire suppression system requirements. So basically, automatic fire suppression system is required if it's inside the enclosure of walk-in units, or battery energy storage on parking levels not open to the sky. So I think you can recognize that if, this is in a parking garage, but on the top level and isn't, being covered with a ceiling, it might be hard to utilize the ceiling as part of their fire suppression system. So you might need to make sure that it's basically inside the enclosure instead. So here we have the specific requirements for the rooftop installations. So you have to make sure that emergency personnel stairway access to the roof, that service walkways from access point to the system are at least 5 feet in width, located away from the edge of the roof, that roofing materials under and within 5 feet of the system are non-combustible. This is also where they have a requirement for the class 1 standpipe outlet installed at the roof location. So that dry standpipe that we had discussed earlier in the presentation, this is now where this is required. And then also the system should be at least 10 feet from the fire service access point on the roof. Once again, I think that makes sense of how, you don't want your firefighters getting to their normal roof access point and there be the system within 10 feet if there's an issue. So you just want to make sure that all of these requirements are on the site plan that the developer is providing you. And then for both rooftops and open parking garages, you want to make sure that basically they're at least 50 feet from the building HVAC air inlets. So these can be made smaller if the automatic fire alarm system monitoring the radiant energy sensing detectors de-energizes ventilation system connected to the air takes upon detection of a fire. But once again, you're just kind of maintaining space around these systems. So here's the open parking garage additional requirements. In addition to avoiding air inlets, open parking garage installations should not be located within 25 feet of exits on covered levels and should be secured with a fence or other barrier to keep people at least 5 feet from the outer enclosure of the system. So basically in that, quick hour and 40 minutes, we just went over all the uniform code requirements for those commercial size systems that you're most likely to see. I would definitely recommend giving a look over to the section 4 of our guidebook to kind of review these again. And then you can also see how they complement our energy storage model law. So now we're just going to take a bit of a quicker review of the requirements of residential systems as portrayed in the 2020 Residential Code of New York, and what protections are in there to help avoid any incidents as well. So here are two images just to give you context of what a residential system looks like. Majority of these projects come pre-packaged and are pretty standardized at this point. So here we have the residential size threshold. So the residential threshold sizes shown here are the 2020 residential code and are subject to basically all the requirements here. Each individual unit may not exceed that 20 kilowatt hours, and systems that exceed these sizes will have to follow the requirements in section 1206 of the Fire Code of New York as applicable. So basically here for storage systems for 1 to 2 family residential dwellings within or outside the structure with an aggregate energy capacity cannot exceed what's listed here below. So 40 kilowatt hours within utility closets, storage, or utility spaces, or 80 kilowatt hours in attached or detached garages and detached accessory structures, 80 kilowatt hours on exterior walls, and 80 kilowatt hours outdoors on the ground. So once again, if they basically surpass any of these thresholds, they will have to go through the fire code. So here is a residential size and separation requirements. So individual units shall have a maximum rating of 20 kilowatt hours. So basically, if your individual unit is greater than that size, they'll be subject to the fire code. But majority of systems, I think, are closer to that 12 to 16 kilowatt hours, and then they're just able to install additional units in the residence. Also, individual battery energy storage units shall be separated from each other by at least 3 feet. And individual units installed outdoors on exterior walls shall be located a minimum of 3 feet from doors and windows. Also, you are unable to install these projects within living spaces. So while the image on the left shows that it's properly installed in a garage, the one on the right is basically showing an installation in your living room, which is not allowable by the code. So for indoor residential systems, rooms that are containing energy storage systems shall be protected by fire resistance rating of 5/8 inch Type X gypsum board or equivalent installed on walls and ceilings. For attached garages, they were to be protected on the system size by fire resistant construction in accordance with the code, which is basically saying that it's a 1 hour fire resistance rating from exposures on both sides. Basically, you know, if there is an incident, which is not very likely, you want to make sure that the fire resistant construction is in place just to make sure it won't spread if there is an issue. Once again, we have a fire detection requirement for residential systems. So smoke alarms shall be installed in the area the energy system is installed. And where smoke alarms cannot be installed, a heat alarm shall be installed and connected to the smoke alarm system. I think most of us probably have smoke alarms throughout our house, which would be sufficient. But when it comes to projects installed in your garage, there seems not always to be smoke alarms installed there. And sometimes a heat alarm will just be installed instead. So you just need to make sure that one of these are installed. So if there is an issue, that an alarm is being sent. So here we have the residential ventilation requirement. Indoor installations of storage that includes batteries that produce hydrogen or other flammable gases during charging shall meet the exhaust ventilation requirements set forth in the applicable fire code. So like I had said previously, lithium-ion batteries do not basically produce hydrogen or flammable gas during normal operation. So if there is potential for release of toxic or highly toxic gas during charging, discharging, and normal use conditions, then also the system should be installed outdoors. The exhaust fans will automatically turn on when these gases reach that 25% of the lower flammability limit of the room. And these ventilation fans will also be needed when a toxic gas is produced during normal charging or discharging. Yeah, so like I said previously, unlike conventional lead acid batteries, which produce hydrogen gas, the individual cells in lithium ions batteries do not require ventilation, as they do not release toxic gas during normal operations. All right, seems we got a question here. So before I ask my quiz question, see some of you are already too quick. So we have a question. So for clarification, the wall the system is installed on needs to be the 1 hour rated assembly, but not the rest of the space. So basically for residential, it will have to be at a minimum installed on the walls and ceilings of the room area. So it only needs to, I believe it only needs to be on the wall that the system's installed on for garage systems. But if it's in your home, the system needs to be basically have the rated assembly for the entire space. And I'd also recommend reviewing the code to make sure that's in line with you're also seeing. All right, since you're all too quick, you can already get into my question. A single family homeowner wants to install a battery energy storage in their garage with the capacity exceeding 80 kilowatt hours. Should it be installed in accordance with section R327 of the New York Residential Code or section 1206 of the New York State Fire Code? And we have a winning consensus again. So the answer is B, section 1206 of the New York State Fire Code. And also here is a picture of a grouping of stacked Tesla power walls. Each is rated around 13.5 kilowatt hours. So grouping of 6 would get you over that 80 kilowatt hour threshold, and then would require you to go through that 1206 fire code. So that's all I have for you today. So, you know, I hope everyone was able to learn something. I know we threw a lot of information at you regarding, you know, what is battery energy storage, how is it being utilized, what are the risks, and then once again, what the code has in place to help mitigate any potential incident that may occur with all the different safety requirements that are necessary. So here you have our general email for the clean energy siting team, which goes directly to my email as well as a few others on my team. So if you have any questions, feel free to email us there, and happy to be of assistance.
Candace, there you go. Thank you. It disappeared for a little while there. So I think you just answered Francis Spinelli's clarification, but do you want to look at Roger's comment in the chat box rather than me read it?
I'm not sure if I'm seeing it.
Okay.
Was it a recent?
In the chat, it's above the, it's going to be above the, I'm sorry, my screen just changed once you did. It's above the last answers, I believe.
I'm only seeing Francis's question.
It should be right above that, I thought. What happened to this? Okay, so I'm going to read it. It's right above Francis's second one. He has one early on we'll go back to, but last time I checked, it was not possible to test the lead acid technology to UL 9450/A, as you had to force the battery into thermal runaway. Therefore, no lead acid battery was listed. Upon contacting UL, they informed us that the standard was intended to cover lithium ion technology. Has this been brought up to NYSERDA? If so, was there a response? If not, can we ask that question? He's been curious about this for some time.
Yeah, so I definitely might, I don't know if we've had direct conversations. I mean, I know I haven't had any conversations with UL about that. I'd have to probably think a little bit more, but I'm happy to continue that conversation offline and see how we can, you know, prepare a better response for you and kind of discuss what's going on. So I definitely don't have a good response right now, as it's the first I'm hearing about it, but happy to continue that conversation offline as well.
Do you want to put your email back on the screen so everyone has it for sure to get back to you with their detailed questions, please?
For sure. I'm not sure why it stopped sharing.
Yep, that's how I got, something happened there because my screens went awry too. So while you're doing that, Francis Spinelli from the city of Newburgh says that they have multiple installations and they often have an issue with installers not getting permits. The code calls for clearances for fire department access, yet they often don't see compliance. I'm assuming you're going to direct them to their city, their buildings department.
Yeah, I mean, they definitely should not be doing that. I know if there is any energy storage projects that are being incentivized by NYSERDA, I believe as part of our like requirements, we also require that they have a building permit to do so. So I would be surprised that they're not going through that. So I would definitely look into that, kind of how you would deal with any other project that wasn't meeting the bare thresholds and minimums for permits. I would also recommend that if you haven't already, to consider adopting a energy storage law to just really codify this is how you're looking at projects. And if you're going to install, no matter like, you know, if it's a 10 kilowatt hour system compared to, you know, a 10,000 kilowatt hours, this is the way that you must move forward in our jurisdiction to get a permit and allow to be installed. So sometimes just getting a law on the books can make it a little more straightforward and clear to ensure that no one's jumping around and basically not meeting your regulations.
All right, please, anyone else have any questions? You could put them in the chat. I'm going to also remind folks that my poll is still open because I did not hear from some of you. So if any of you have anything to say, that would be great there. I also want to bring up a question that, you know, you threw out a lot to us, Candace. Moving forward in the urban environment, where do you see the best application for these? Because every time I thought I had something, then you went and said, well, it's got to be 100 feet from this or 10 feet from this. You know, this needs to be an urban environment. So I am saying the city, as you quoted a few times, but even then, when you bring it back for me, future planning, keeping things closer, walkable, our villages are in Orange County or maybe even across the state should be where the development is being planned in order to mitigate transportation. So where do you see this exactly happening? You know, you said garages, open garages. So does it have to be 10 feet from the top of the above floor? Are you putting it on the rooftop of the garages? And then it's just,
I think we're seeing majority of installations falling into that outdoor remote. So basically similar to where you're seeing those community solar farms, a lot of them are pairing with energy storage. So I haven't seen too many in like the city centers outside of New York City, which has been another tremendous effort to get the fire department along with DOB on board to get anything permitted in New York City. So they have, you know, been very conscious of any like threat to human health. And obviously New York City is kind of a different beast. We did see a project in Yorktown, which was in the parking lot of a kind of a strip mall. They had paired that with a solar project that was on the roof of the strip mall. So we have been seeing some, I would say, more in those kind of areas and just making sure that they have the protections around that to make sure no one drives into them. But I would say we see majority of these projects being paired with those larger solar systems.
Okay, so that's what we're full of in the city. You have the buildings, so if you do get PV on them and PV over the parking lots, then you have your energy storage nearby meeting all the guidelines discussed here. Brownfields, we have a lot of those in the city. That could be something that could be used. But now again, I come back to Orange County, areas of population, villages probably, maybe even hamlets. Do we just focus on then commercial buildings with their roofs and their parking lots and the malls, like you said? I mean, in the Home Depots, et cetera. Is that where NYSERDA sees the logical direction for this?
So I won't speak all for NYSERDA on where we see it going, more or less, because I'm not part of the energy storage team that deals with most of the incentives and where the thing's going. For our siting team, we are mostly just working on providing this sort of code information and like how you can prepare for it. But like I said, I think a lot of it is similar to where you're seeing solar installations. They're being paired together. And once again, you can give a look at like your hosting capacity maps, because besides like, as you said, near a Home Depot, they'll still need to be close to any of the 3-phase lines to be able to, charge and discharge power if they're not paired with a solar system. So you can check out the Orange and Rockland hosting capacity maps as well. But I think, at least from my initial perspective, a lot of them are just going to be paired with solar systems across the state.
And that makes sense. It's just in our mixed county where we have important farms, very important for the economy, for our open space, and we have these great soils there. We don't necessarily want all the solar going there. We want to use the brownfields and the roofs first, and I know the state understands that. So I'm just trying to realistically know, where do we go? And I guess I would appreciate if you could do a follow-up to me, maybe later, get some more of where NYSERDA thinks it's going to go in villages, and if there'll be any incentives, so that when a new Lowe's or Home Depot comes, which they probably won't, but other buildings, when another warehouse comes to Orange County, and they are coming, we could say, okay, this is what you need to consider. So that's the next, I guess that's the homework. And I know the state knows that, but we have to get away from using our agricultural properties and in deferring to adaptive reuse of our inner cities. And I see Paul Puller agrees with me. I've been a proponent of parking lots, and he said it cools the cars. It's a win-win. The macadam lasts longer. It's just such a good thing to cover the parking lots. So I'm hoping we see some of that. Jersey's been doing it for years. We know communities out west and down south have been. Anything else before we wrap it up? We want to let you go to lunch. Candace, do you have any closing thoughts?
No, I think just happy to be here and be a resource. So I'm sure if you send out the slides, I'm happy to just give my direct contact information as well. But just happy to be a resource as your town goes through this process of, permitting. And if you're looking at adopting laws, we're happy to just be as much of a resource as we can here at NYSERDA.
All right, great. Well, if you have any additional questions, Candace and I can stay on a little bit, but I know you're hungry. Go eat lunch. And I'd like to remind you that we're having another one tomorrow, more for permitting and for building inspectors, code enforcers. But I mean, Candace, could you speak to that? It is some of similar information. Always good to hear again. Tell your colleagues, tell your friends.
Yeah, tomorrow's presentation, it will be directly focused on solar PV permitting inspecting. So walking through how you can permit these projects, what to look for in your design review, and more focused, I would say, on a residential basis, but things that can be applied for commercial solar systems as well.
So that same bat channel, same bat time, 10 o'clock to 12 o'clock. We hope to see you then. Thanks all.